The last type of reactions we're going to look at are what are known as oxidation-reduction reactions. These occur when electrons go from one atom or ion to another. We also often use the shorthand term redox to describe these type of reactions. Anytime something reacts with oxygen, it is a redox reaction. 99% of the time, oxygen gains the electrons. Unlike the other reactions we've talked about, these do not have to occur in water. Let's look at some vocab. The element that loses electrons during a redox reaction is oxidized. The substance that gains electrons is reduced. If something loses electrons, something else gains electrons. You cannot have one without the other. And in most reactions with oxygen, oxygen is reduced and the other material is oxidized. So why, if something is gaining electrons, is it called reduction? Well, remember, electrons have a negative charge, and so if something gains electrons like oxygen, then its charge becomes more negative or reduced. So here are two little mnemonic devices you can use to remember these terms. Here's oil rig. Oxidation involves losing electrons, reduction involves gaining electrons. Or Leo the lion says grr. Losing electrons is oxidation, gaining electrons is reduction. And here again is the example of a reduction of oxygen atom. If it gains 2 electrons, it's reduced. And here's an oxidation example. Calcium atom loses 2 electrons, it gains a positive charge, and that's oxidation. So here we have a typical example of an oxidation-reduction reaction. Here we have a metal reacting with oxygen to form an ionic compound, or the metal oxide. Once the ionic compound is formed, we have ions. The magnesium has a +2 charge, it has lost electrons, and the oxygen has a -2 charge. It has gained electrons. So we have a redox reaction. Magnesium, or the metal, is oxidized and the oxygen is reduced. If we look at the reaction the way that it's written, there's no mention of electrons anywhere. You have to know that this is an ionic compound with charged ions making it up. You also have to know the charges of the ions to figure out which one is oxidized and which one is reduced. Now, combustion is a redox reaction even though ions aren't specifically formed. Any time an atom gains oxygen in a reaction, it's oxidized. So if we look at this combustion reaction of methane, carbon gains oxygen, it's oxidized. Anytime something gains hydrogen, it's reduced. And typically in reactions with oxygen, oxygen is going to be the one gaining electrons, so therefore it's going to be reduced, and the other material is going to be oxidized. So how can you tell when a redox reaction occurs? When a substance reacts with oxygen, redox is occurring. When a metal combines with nonmetal, or whenever charges change, and that indicates that electrons are transferred if the charges change. So let's look a little bit at this last one, any reaction where electrons are transferred. Sometimes that might be hard to identify. We're going to look at ways to identify that clearly. Whenever an element reacts to form a compound, or any time an element is formed in a reaction, that is a redox reaction. So this would be a redox reaction. Also, if charges change. On this side of our equation, copper has a +1 charge. On this side, it has a +2. It has lost an electron, so that means redox has occurred. Here, on the reactant side, iron has a +3 charge, and over here it has a +2. It has gained an electron, or it has gotten reduced. So, anytime you see oxygen, a metal or a nonmetal, anytime elements either react or are formed, and anytime something changes its charge, redox has occurred. So pause the slide and see if you can decide whether each of these are redox. And then once you've gotten a decision, turn the lecture back on and we'll go over it. So yes, this is a redox reaction. We have a metal and a non-metal reacting, or you can look at it as elements reacting. So anytime that happens, it's a redox. No, this doesn't fall into any of our categories. We don't have oxygen reacting, we don't have elements reacting or formed, and nothing changes charge. Here we have calcium over here, which is +2, and calcium is +2 over here. We do have this. If you notice this is -2, you might think that it's changing charge, but because it loses its oxygen, it really doesn't. So this is not a redox. Here, yes, this is. If we look at this, we have an element reacting and an element formed and something that gains oxygen. So a redox reaction did occur, and here this is a redox reaction. Oxygen is a reactant. Anytime oxygen is a reactant, we have redox occurring. Now let's look at a type of redox reaction that's known as combustion. The combustion is a reaction with oxygen, and it is always exothermic, meaning a lot of heat is given off. These are oxidation reactions, and anytime something with carbon and hydrogen reacts with oxygen, carbon dioxide and water are always formed. So let's look at the reactant and what the combustion products are going to be. If the reactant contains carbon, your combustion product is going to contain carbon dioxide. And remember, combustion is the reaction with oxygen. If your reactant contains hydrogen, water as a gas is going to form. And it's going to form as a gas because so much heat is evolved, the water is going to vaporize. If your reactant contains sulfur, you're going to form sulfur dioxide as a gas, because sulfur dioxide is a gas at room temperature. And then if it contains nitrogen, it's going to form nitrogen monoxide or nitrogen dioxide. And if your reactant contains a metal, then the metal oxide is going to form, and its formula is going to be determined by the charge of the metal. Remember, the oxygen in an oxide always has a charge of -2. So using these rules, pause the slide and see if you can write the balanced equation for the combustion of cyclopropane, C3H6, and propylene glycol, C3H8O2. Okay, so you notice that this reactant has both carbon and hydrogen in it, so the products are going to be carbon dioxide gas and water gas. Then to balance it, so we get a whole number with our oxygen, we have 2 cyclopropanes, 9 oxygen, 6 carbon dioxide, and 6 waters. And then here is our propylene glycol. To balance this, so we have an even number or a whole number in all of our coefficients, we have 2 of this molecule, 7 oxygens, 6 carbon dioxides, and 6 waters. And what you needed to know is that carbon dioxide and water were the products of both of these combustion reactions, because our reactant has carbon and hydrogen in it.